Hey there, have you ever created a variable in your code, used it exactly one time, and then never touched it again? Well, in this explainer, we're going to talk about a really clever Java feature made for that exact scenario: anonymous objects. Think of them as single-use tools in your programming toolkit, designed to make your code cleaner and more efficient. Let's dive right in.
So here's our game plan. We're going to start on solid ground with the standard objects you already know. Then we'll take a peek under the hood to see how they really work in memory. That's super important because from there we'll jump into the world of anonymous objects, what they are, when you should use them, their one big limitation, and then we'll wrap it up with a side-by-side comparison.
All right, first things first. Before we get into the new stuff, we've got to make sure we're all on the same page with the basics. So let's have a quick refresher on the standard everyday way we create objects in Java. This line of code right here should look incredibly familiar. We've got a class, let's call it A, and we're creating an instance of it that we're naming obj. This is Java 101. But if you ever really stop to think about what this simple line is actually doing inside the computer's memory, well, the truth is, that single line of code is actually doing two completely separate jobs. And really understanding this separation, that is the absolute key to unlocking the whole concept of anonymous objects.
So let's break it down. You've got the part on the left of the equal sign, aobj, and you've got the part on the right, new aoo. They're written together, but they represent two totally different things happening in two different places in memory.
Okay, let's really get into this memory model. On the left side, you have the aob part. This isn't the object itself, it's just a reference variable. Think of it like a name tag or a label that lives in a super fast area of memory called the stack. Now, look to the right. The new A part is the command that actually builds the object in a much larger memory space called the heap. The heap is where the real thing, the instance with all its data and methods, actually lives.
So here's how they're connected. That object variable, our little name tag sitting in the stack, its only job is to hold the memory address that points directly to the actual object living over in the heap. The reference is our remote control for the object.
And this brings us to a really fascinating question. If the object variable is just a name tag, just a pointer, what if we only need to use the object one single time? Do we really need to bother giving it a name at all?
And that question leads us directly to our main event. An anonymous object is exactly what it sounds like. It's an object that has no name. We create it, but we never assign it to a reference variable. It's an unnamed entity, plain and simple. And the syntax for it could not be simpler. We just use the part that creates the object, new A, and we completely leave out the A object part. We're telling Java, hey, build me one of these, but we're not bothering to create a named variable to hold on to it.
So, how does this change our memory map?
Well, the object still gets created in the heap, just like it did before, but, and this is the whole point, the stack is empty. There's no object variable, no name tag, and because of that, no pointer leading back to our object. It exists, but it's adrift and nameless.
Okay, so we can create an object without a name. That's neat. But why would we want to? This is where the practical side comes in. Anonymous objects are designed for a very specific job.
And here it is. The number one use case is for an immediate one-time action. In this single line, we create a new object of class A, and in the very same motion, without ever naming it, we immediately call its show method. We create it, we use it, and then we're done. Fire and forget.
I love this analogy because it makes the idea so clear. A standard, referenced object is like saving a friend's number in your contacts. You give it a name, and you can call them anytime you want using that name. An anonymous object, on the other hand, is like seeing a phone number on a flyer for a concert. You dial it once to get the info you need, and then you forget it. You never save it because you only needed it for that single immediate purpose.
This brings us to the most important rule about anonymous objects. They are strictly a use it and lose it kind of deal. Once that single line of code is executed, that object is gone from our reach forever.
So a natural question comes up. What happens here? Are we calling the show method on the same object twice? Or is something else going on?
The answer is two. This code creates two completely separate and distinct objects. And here's the key takeaway. Every single time Java sees the new keyword, it builds a brand new object. No ifs, ands, or buts. So in our example, that first line creates an object, calls its method, and then, since we have no reference to it, that object is lost to us. The second line then repeats the entire process, creating a second, completely different object. There's just no way to get back to the first one.
All right, let's wrap this all up by putting everything we've learned into a direct side-by-side comparison. This should make the differences perfectly clear.
This table really puts it all together. You can see the trade-off, right? With a standard referenced object, you get reusability, but the syntax is a tiny bit longer, and you use memory in both the stack and the heap. With an anonymous object, you get super clean code for single-use tasks, and you don't clutter the stack, but you totally sacrifice the ability to ever use that object again. It's all about choosing the right tool for the job.
So, I'll leave you with this question to chew on. Now that you understand these unnamed helpers, where in your own coding projects could you use an anonymous object to get rid of a temporary variable and make your code just that little bit cleaner and more direct?